So my name is Jakub Dardziński. I'm from Getting Data. I'm the OpenLineage committer and let's say maintainer too. I also do commit to Airflow. Today I want to talk about extracting lineage from PythonOperator, which seems to be quite impossible. But let's see if we can find any solution. So first, let's identify the problem. So why do we even care about PythonOperator at all? And I have a question to you. How many of you have used Airflow and saw or wrote some Python method code with PythonOperator in production? So I assume that many of you. I can see, but I saw it too. And the reason is that PythonOperator is quite flexible. You can do whatever you want basically there with Python code. And yet there are 73 providers. I checked it today with over 800 operators total. Some of them don't work, are not up to date, or have some different purpose. We want to change something, and we write new custom operator or just use PythonOperator instead. And that's, I think, the reason for PythonOperator being the most popular operator still. And another reason is that Airflow also introduced TaskFlow API that lets you even easier cooperate with Python code and tasks and moving data around without dealing with XCOMs explicitly. So as I said, it allows you, the PythonOperator allows you to run any code, and that's the problem basically. So you can, for example, fetch the data with request library, then call some other DB client, upload it with GCS client, for example, then do something else. And well, if we want to integrate OpenLineage with all of these libraries, it's like basically impossible for us. We cannot analyze the code and say, hey, it's doing something, moving data from place A to place B. We cannot patch every library, keep it up to date. It's just impossible for us. So one thing that we could do, and it's kind of working, is to use TaskFlow API with Airflow datasets. So the code that is on the left might be replaced with the code on the right. So you can define dataset that has some URL or URI. You can use this dataset, move it around different tasks, and the lineage is generated. The task flow works in a way that inlets and outlets are generated for each of these tasks. But there are limits of that because it requires you to manually set up the Airflow dataset. Not everything can be expressed with Airflow dataset for now. And you need to split the whole work that should be done with the Python code just to generate lineage. And sometimes you don't want to split it because it's a one huge job that should be executed within one task. So before I propose a solution to the problem, I want to shortly talk about current state of OpenLineage in Airflow. So first version of OpenLineage provider was released on August 1st this year. It's an implementation of AIP 53 proposed by Julian Ledam, and it works with Apache Airflow greater than 2.7. It's a huge step for OpenLineage because it became a part of Airflow's code base, and relating to what Pavel said previously, with Spark, you need to deal with different versions of Spark, Scala, Iceberg, etc. We had the same issue with Airflow and Airflow providers. We needed to catch up with changes in BigQuery, with Snowflake, and other providers as well, and patch the whole code just to make sure that it works. So now we are part of Airflow's code base. Whenever the tests in CI break after we add something new with OpenLineage, well, it breaks because we need to make something up to date. Shortly about implementation. So the idea is to have each operator exposing Lineage themselves. The Lineage contract is exposed by some data structure from OpenLineage provider. And for each operator, we can define get OpenLineage facets on start / complete / failure methods, so that they are executed before or after task execution. Here's the example for GCS to GCS operator. This is actual code. So it looks pretty simple, and it is simple. We just gather what has been defined as source and target objects and translate it to input and output data sets in OpenLineage. But this implementation, in terms of PythonOperator, has its limitations. First, it all happens on operators level, so we cannot intercept Python code. We cannot see what's really happening inside. And well, to remind you, PythonOperator can run any Python code, basically. So just because we cannot, well, go into the task execution within PythonOperator, we like to propose some other solution to have lineage collector, hook level lineage. The hook is optional here. I explain it in a moment. But the idea is to have lineage collector that is singleton instance, receiving information about inputs and outputs during tasks execution. So whenever we use some hooks or whatever that could send information about inputs or outputs, we collect it, and after the task execution, we can create and emit OpenLineage event as well. But this is not ideal still. It helps because we still need to find places and define some explicit calls to send such information. So for example, in GCS hook, in copy method, we could add to such calls to add input dataset and output dataset, and without using some other operator that makes use of this method, this copy method. But PythonOperator would use that instead. We would have this lineage information sent and emitted to OpenLineage. The other drawback is that you need to use Airflow hooks. So instead of requests, you should use HTTP hook, and etc. etc. I'm not really sure how many people use hooks instead of raw libraries, but like for me, at least, the benefit of using hooks is that it's well implemented yet already. You can use connections well with all profits from it, so you don't need to deal with passwords, etc., because it's all contained in Airflow. But still, you need to do some manual job to rewrite the code for hooks. The other thing is that it doesn't necessarily need to use only hooks. Airflow hooks. So for example, I think Pandas is one of the most common libraries used in PythonOperator as well. So here's the example of like hooking into reading CSV from Pandas, getting the name of file name that of file path of this CSV file, and also reading the schema of the file straight from the Pandas attribute. So I prepared a short demo with something that would show such thing. So this is a simple DAG that just fetches the data from some public. Yeah, for all people, I can do that. Can you see it now? Okay. So you can. So the first task just retrieves the data from some public endpoint via HTTP hook, then saves it with Pandas to some other file, and the other task just reads the file, selects some columns, and saves it to some other CSV file. So for Pandas, well, this is pretty simple. It's just the POC, but I'm hooking into two CSV and read CSV methods, and I'm reading the file path and the schema. For HTTP hook, this is pretty simple because I'm adding the add input dataset line here only. So let's try to run the code using Breeze with OpenLineage integration. So it ran here, and what we would expect here is that the first task is getting the CSV file from HTTP, then it saves it to CSV with schema of it. Sorry. It contains the schema. There is then another job that takes the first CSV file as input and uses the other as output with changed schema here. So this is short just to show that it might work. So this is under design, and for sure it requires core changes in Airflow. And because this is a core change, it won't be released sooner than 2.9. There is lots of things probably to be covered here. The other thing is that Airflow and OpenLineage datasets are kind of similar now, but they could be converged so that they could influence one on each other. So right now, Airflow dataset, whenever there is some event registered on Airflow dataset, we could emit some additional OpenLineage. We could emit some additional OpenLineage event, and in opposite, we could parse and create OpenLineage datasets as inlets and outlets, and let Airflow know that some dataset had been changed. So that would be bidirectional profit for Airflow and OpenLineage. There is also AAP58. It's an ongoing task as far as I know. The object store is a way to express datasets as light, let's say, interfaces, a table or file or whatever the place is, the object, and use them instead of using hooks or operators explicitly, just to move data around. So we would like to instrument this object store as well to emit the same data, also from PythonOperator as well. But PythonOperator is not the only one that can run arbitrary code. We have Kubernetes pod operator or Python a virtual env operator, but this might be a bit harder. I'm just like noticing that this is on the table as well. So that's it. And if you have any questions, I try to answer.
So thank you for talking. I have a question because you show us in this demo that you convert to CSV file, and can you show us what's inside the CSV file, or just?
I could. Sorry. I'm not sure where it is right now. No, I cannot.
Okay.
Sorry, I don't have the path here. But why do you ask?
That's more interesting.
Okay, so you don't believe me.
What's inside?
But you can actually show the schema, right? You know what the format of the file is.
So it's just some IMDb database, as far as I know. So sorry, I wasn't prepared for showing the data.
So, like, you know, everything in Airflow, you have a lot of everything, a lot of operators, a lot of hooks, and you are probably going to address some of them initially to instrument them. Are you thinking about making it like easy for all the other contributors to make their own instrumentation to other hooks that are there? What kind of mechanism have you thought about?
What do you mean by easy?
Encourage, make it very straightforward, document, guide them. That's basically what I mean. I think that's like, if you really want to get like every hook in Airflow to be converted, you actually need to have this, that people will want to do it.
I would say that there are two answers for that. One is, yeah, it's pretty simple because you should just find the place when the input or output is generated. So how hard could that be, right? But on the other hand, I know that there are some like discrepancies, like how do you know how to define what's the namespace or the name of the data set, right? That's something that we still need to work on to provide some better guidance, how to express data set in terms of OpenLineage. I think, well, it's not isolated to OpenLineage itself, because Airflow has the same problem, I think, because you can name data set with URI, whatever it is, right? But I think we need to standardize it somehow and converge again Airflow and OpenLineage datasets. We have some naming convention, but for sure it requires some more work.
If you need help, if you need help, I'm happy to. At the point when we start discussing things, to try to get some more help to encourage people to contribute.
Yeah, for sure. And I think we are close to like going public with the whole discussion. Yeah.
I just want to add that we might want to work from the opposite direction. And our idea is to have this whole like Airflow data system, OpenLineage, DAG, data-aware scheduling package so attractive to users that they will want hook developers to implement all of it. Because there are some efforts that are maybe too early to talk about, but basically combining all of it makes working with like pretty standard CSV, Parquet, stuff like that data way easier than anything before, I would say. So the whole idea is that users will want to write this way. So yeah.
Yeah, but we can't really tell like what's the order, what will be released or not. So this is just some idea.
Just show a green light to this.
Okay, sorry. I might have missed something, but is there an effort, like how would column lineage work with, let's say, pandas? Is there any effort on tracking that?
I gotta be honest that pandas is only POC just to explore how to easily hook into these methods. Well, the best answer is to ask pandas developers to help us. I'm not sure how that would go. We can try, but I gotta be honest that I don't know. Like, I don't know how hard it is to track column lineage in pandas. Maybe it's easy, maybe it's not. Yeah.
Okay, thanks. I was just curious if anyone is working on that already.
Hey, so we've been showing HTTP example. How about some other hooks? Imagine like hooks based on some other protocols. Would the approach to implementing such lineage extraction be somewhat unified across different protocol types, or would it be, case by case, figure out what you need?
Honestly, I don't know. The reason I speak about it here is that there are some items that are brought up here, and it's good that we can discuss about it, right? Some of them are not clear. Some of them need some more discussion. And probably some of you think that, hey, this is stupid, maybe. So I just invite you to contribute, even if you just want to express what you feel about it. Maybe you have better ideas. I don't know. So
I think it's a fair topic to discuss. Like once the discussion goes publicly, let's try to find some nice way to do it. Yeah.
So yeah, it's very early and we don't know yet what will happen, but one idea is that perhaps hooks will define, or like providers will define the actual dataset types, which will be those Airflow datasets that will be like easily convertible to OpenLineage datasets because we know what they are. They are not arbitrary URLs then. And then the hook will understand that in some ways, I know HTTP hook produces HTTP dataset, or GCS hook produces GCS dataset. Then, stuff like bucket and path in that bucket are understandable to it. So that's one idea how to do this. Basically, another like entity in the provider.
yeah, but that's it. Work more on datasets rather than on hooks, I think.
Yeah, those who could emit those datasets, right? That's that. Still, you would need to instrument the hook, but you would know what kind of entity it produces, right?
Potentially have a check. Following what we are already doing in Airflow, so we could potentially have a check, like describe what do you expect from given provider and given hooks are coming, as you said, and then make either even like some kind of automated way of previewing things that should be implemented there, or things that like how you are like what you should instrument, or just flagging that instrumentation is needed here to be done if it's not done. So that would be kind of guideline for people contributing. Okay, here these hooks still need some love when it comes to integration with OpenLineage. Yeah, so I think this would be pretty doable, and following a lot of the things that we do in Airflow in the past, like how we were implementing this kind of bulk implementation of some idea in the whole code base. We could probably work out something like that. I'm happy to help with that.
Maybe one thing, right? And not everything has to have those data sets, lineage collection, because a lot of those operators aren't basically working on data, right? If something is creating a bucket or deleting your network in Google Cloud, it's not exactly a data operation. Same as like sending a message to Slack. So the pool is much smaller, and the pool that people actually use is even smaller. So the important thing is to focus on that.
Right.
Maybe, are there any more questions from the virtual audience? No? Okay, thank you very much, cool.
Thank you.